Hello and welcome to Pep Talk with me, Mr. Pepperell. Today I'm thinking about conduction and how heat energy is transferred through a solid. By the end of this video you should understand what materials are good conductors, what materials are good insulators, why metals are so good at conducting heat, and why non-metals are so poor at conducting heat.
So, if you've ever been cooking and you were using metal utensils like this spoon to stir your beans, for example, in there, you might have noticed after a little while that suddenly the end of the spoon, ow, it was very hot, okay? But how is it that the heat has been transferred from in the saucepan here along the spoon to your hand? Well, it's by a process called conduction. And to understand this, we need to think about the particles or the atoms that our metal spoon is made from. So you may recall from before that particles in a solid like a metal are very close to each other and are held in these fixed positions, and that's quite important, okay? Because when we start to heat an area of material like metal, what we're doing is giving the particles that we heat more kinetic energy, okay? So we're giving these particles here, exactly where the flame is, more kinetic energy. And as we give them more energy to the particles, they start to vibrate more. Remember, they're already vibrating, so never say they start to vibrate. They just start to vibrate more, okay? Now, as these particles here, directly next to the flame, start to vibrate more, what they do is they collide with the particles next to them. Okay, so they start to bang into the particles next to them. So you can see this transfers energy to these particles. So now we've got a bigger vibrating area. And of course, this vibrating area, these particles here start to collide with their neighbours, and that vibration starts to spread. The energy, the kinetic energy, is being passed along the material, and basically this is conduction. So the process of conduction will occur in all solids, but some materials, and namely metals, are much better conductors than others, and there's a reason why. Okay, it's because metals actually contain a lot of something called free electrons. Okay, now these are electrons that are not confined to orbit the nucleus of their atoms like you might expect electrons to do. What they can do is move about randomly inside the metal, and they hold the positive metal ions together. While they're doing this, though, they can collide with each other and they can collide with the positively charged ions, and that's important for conduction. Now, think back to our metal spoon before. Say this little area of my metal spoon, I've got a close-up of it here, okay? And if we heat one area, say this end of my metal spoon, my free electrons, and this is one of my free electrons moving about here, okay? Those free electrons in that area start to gain more kinetic energy. Okay, and when these electrons gain kinetic energy, they start to diffuse through the metal. They're not confined to orbit the nucleus of the atom they belong to. Okay, they actually what we call delocalize, and they can diffuse through the metal. And as they do so, as they start to diffuse through the metal, they start to collide with other particles. Okay, up through the metal, transferring their kinetic energy to them. Okay, and in this way, all I need to do is heat one area of metal, my electrons can then whiz off, bumping into other particles as they go, transferring their kinetic energy. And in this way, the heat is really easily and really rapidly spread through the metal. So that's what makes metal such a good conductor of heat, and hopefully you might sort of guess now what makes other materials like wood or like glass such poor conductors of heat, and the name for a poor conductor of heat is an insulator. Okay, so non-metallic materials like wood or like glass, okay, don't have any free electrons. If we take a close-up of my spoon here, so take this area of my spoon and take a close-up, we can see that, yeah, the atoms are there that the spoon is made out of, but there's no free electrons. So if I heat one end of my spoon, the only way the energy can be transferred between the particles is for the atoms themselves to vibrate and shake each other. Now, this isn't a very effective way to transfer the energy, so the heat doesn't spread very easily up through the spoon like it did with the metal spoon before. The heat's not spread easily, and we say these materials are good insulators. So to summarise what we've said there, metals, and actually in particular copper, are good conductors of heat due to their free electrons. If we look at this infrared image here, we can see that the heat from the stove there is being conducted easily through this metal saucepan. Okay, But materials like glass or wood that this spoon is made of, we can see here that the spoon is cold relative to the metal saucepan. We say that they are poor conductors or insulators, and that's because they have no free electrons.
So that's it for this episode of Pep Talk on conduction, conductors and insulators. Any problems at all, don't hesitate to tweet me at Mr_Pepperell or email me and I'll get back to you ASAP. Thanks for stopping by.